Now that we understand what a tangent line is, let's see how we can estimate its slope. Remember, the tangent line represents the instantaneous rate of change, but we don't yet know how to compute it directly. So instead, we'll approximate it using secant lines. We are given the function f of x equals x squared, and we want to estimate the slope of a tangent line at x equals 2. That means we want the slope at the point where x equals 2. When x equals 2, f of 2 is 2 squared, which is 4. So we have the point 2, 4. We want to estimate the slope of a tangent line at this point. Question A, they want us to use the point 3, 9 to estimate the slope of a tangent line at the point 2, 4. So let's plot 3, 9 on the graph. We are going to use the slope of the secant line between these 2 points. The formula of the slope of a secant line is f of x minus f of a over x minus a. F of x is the output of the second point, which is 9. F of a is the output of the first point, which is 4. X is the input of the second point, which is 3. And a is the input of the first point, which is 2. 9 minus 4 is 5, and 3 minus 2 is 1. So, the slope of the secant line between these 2 points is 5. This means the average rate of change between x equals 2 and x equals 3 is 5. But is that the exact slope at x equals 2? Nope. It's just an approximation. Now, let's bring the second point closer. Instead of 3, 9, we now use the point 2.5, 6.25. So instead of 3, 9 here, we bring it closer to here. So now, our 2 points are 2, 4 and 2.5, 6.25. Let's find the slope. F of x is the output of the second point, which is 6.25. F of a is the output of the first point, which is 4. X is the input of the second point, which is 2.5. A is the input of the first point, which is 2. 6.25 minus 4 is 2.25. And 2.5 minus 2 is 0.5. 2.25 divided by 0.5 is 4.5. The slope of the secant line between these 2 points is 4.5. Notice something? The slope was 5 before. Now it's 4.5. It's changed. As the second point moves closer and closer to 2, the slope of the secant line is changing. And it seems to be getting closer to a certain number. If we keep choosing the points closer and closer to 2, the slopes would keep getting closer to the true slope at exactly 2. That number the slopes are approaching to, that is the derivative. That is the slope of the tangent line. So here's what's happening. Secant slopes give us approximations. As the points get closer, the slopes approach the true instantaneous slope. And in the next part, we'll learn how to find that exact value.